Welcome to this Flight Global production in association with Rolls-Royce. My name is Murdo Morrison. I'm here in Derby, home of Rolls-Royce and its illustrious family of Trent wide-body turbofans. We're in the aftermarket support facility where Rolls-Royce is changing high-pressure turbine blades on the Trent 1000 to get the latest enhancements to its customers as soon as possible. And it's those improvements we're going to be focusing on today. The Rolls-Royce Trent 1000 went into service in 2011 as one of two competitive engines on the Boeing 787 Dreamliner. Although optimised for the all-new wide-body, rising thrust demands on the power plant over the years led to the engine experiencing durability issues, particularly with a high-pressure turbine in the hot section of the engine. Although this has had an effect on the programme's prospects, Rolls-Royce has been working hard on its latest durability enhancement, now being rolled out in both new production engines and through the MRO network, and it believes it will have a profound impact on market perceptions. To discuss this and more, I'm joined by Rachel Walker, Senior Vice President for the Trent 1000. So Rachel, welcome. How long have you led the Trent 1000 programme and what does the job involve?
So I have personally been leading the Trent 1000 programme for around 6 months now, but I've been on the journey for over 2 years. Essentially, my role right now is to be accountable for all things Trent 1000 within Rolls-Royce, be that introduction product improvements or management of the business plan, day-to-day management of the P&L. And essentially my team operate as the gearbox into the wider Rolls-Royce, and on our customers' behalf and on the business's behalf, we ensure that the business is delivering all things, be that design modifications or the right fleet management for our customers or customer engagements, etc., etc.
Okay, so for those who perhaps don't know, tell us a little bit about the Trent 1000. It was designed specifically for the Boeing 787. Just tell us when it first flew, when did it go into service, what was its heritage, and what was Rolls-Royce trying to achieve with the Trent 1000?
Well, we very much set out our journey to offer up a very competitive, efficient engine on the outset for the 787 platform, both in terms of fuel efficiency, but also weight efficiency was very important for that airframe as well. So we first flew the engine, ironically, as far back as 2007 when we did our first flying test bed, but it ultimately entered into service then in 2011. Since then, we've continued to improve the product as the needs of the aircraft have grown. So we actually have 4 different Trent 1000 variants out in our fleet now, with the latest edition being the XE, which is the durability enhanced version that we've just recently released.
Okay. And interestingly, of course, the 787 is the only in-production wide-body for which customers have a choice of engines. It competes with the GE Aerospace GEnx. How does that alter things for you at Rolls-Royce? What are the qualities of the 787, and how do you approach the market differently to say how you would with the A350, with the Trent XWB, which is the sole option on that aircraft?
Well, I think I'll start with, we believe particularly with the durability enhancements we've just released, we believe we have a very competitive product, which is, first and foremost, very, very important. It's highly efficient, as I said, for fuel efficiency. It's a very reliable product, and now we have a very durable product as well. We couple that then with our total care offering, which is essentially designed to be bespoke for every single customer. So how we approach campaigns is to understand what are the wants and needs of the customer, what do they value, and how do we best serve those needs. And we're able to tailor our total care offering so that it is entirely bespoke to every single customer, and that's something that, again, is something they highly value and something that's very competitive for us. So your question's interesting around how does it compare with, for example, an XWB on the A350. Fundamentally, we would take the same approach. We offer a very highly competitive product, and we wrap a very bespoke total care offering that serves our customers' needs around that. So the approaches are actually quite similar.
Okay, that's interesting. And that, you mentioned there the enhancements, and that brings me to perhaps the main part of our conversation. Some customers have been quite vocal about the durability issues with the engine, and Rolls-Royce has been quite open about the need to improve its time on wing. How have you been approaching that challenge?
Well, maybe start with a bit of a context there. So I mentioned the product needed to evolve with the growing needs of the aircraft. So what we found is as the weight of the aircraft increased, as the thrust needs of the aircraft grew, some of the components, particularly in the hot end of the engine, struggled to really cope with the extra strain that was being put on them, particularly the high pressure turbine blade. These are components to work in the most strenuous and hottest part of the engine. And what we needed to do to rectify that was introduce some durability enhancements. Those were largely focused on fixing that component, and that was done in two phases. First phase, we looked at how do we better cool that component so it can survive those really hot gases that it's subjected to. And then the second phase focused more on reducing the weight, so it reduced the stresses on that component as well. What that ultimately has done is enabled us to up to triple the time on wing for our customers, and the benefit that that brings to them then is much more stable and certain fleet management for them. It's a significantly reduced maintenance burden, as well as just that seamless operation where they can just keep engines on wing longer is hugely valuable for them. Now, we recognise this was causing our customers hurt, so we have absolutely been running at this at pace. So we first introduced the Phase 1 in June 2025. We have been installing that at rate through our fleets, and we have around more than a third now of the fleet has that modification installed. The Phase 2 improvement beyond that is very pleased to say the very first one's just come out of one of our MRO shops recently. So we are going to have the same pace and intensity to get that installed through the fleet as well.
So what comes next then? What's next with that Phase 2?
So we are aiming to have the whole fleet installed with the XE, which is either the Phase 1 or the Phase 2, because both are a significant upgrade to time on wing by the end of 2027. And we are laser focused on that rollout. Coupled with that, we have also been investing significantly in our MR&O network, and we'll continue to do that right up to 2030. So we've significantly improved the amount of capacity that's available to overhaul the engines. So the combination of the improved time on wing plus an increased amount of capacity in our shops builds us a really resilient future to be able to serve all of our future customer needs for overhaul going forwards.
And these improvements, of course, are on your new build engines as well as on the engines going through overhaul. Correct,
yes. So all new engines from here on in will enjoy the Phase 2 durability enhancement. And we've had a few that have already are flying around with existing customers with the Phase 1 as well.
Okay. And you touched on this, Rachel, already, but maybe just explain to me what exactly is the role of the high pressure turbine and the blade in that hot section of the engine, and why is it so crucial to durability?
Yeah, good question. So the HP turbine blade's role is basically to extract energy from the hot gases that come from the combustor. It then uses that energy to turn a shaft that's connected to the high pressure compressor that is then compressing the air that goes into the combustor. The reason why these are so important for durability, as I said earlier, they are the hardest working components in the whole of the engine. They're subjected to temperatures of 1950 Kelvin, extremely hot, close to the melting point of the material they're made from. And they're also subjected to those extreme loads. They're rotating at thousands of revs per minute. And what that means is, the kind of stress, if I can liken it to in layman's terms, is a double-decker bus essentially attached to the end of the blade, and that's the kind of load that this component has to endure. So it's fascinating if you're an engineer like me to see the science that goes in and the engineering precision that needs to go into these components. And that's why they are some of the most sophisticated components in our engine. The reason why they're important for durability, therefore, is they could be the first thing that drives an engine to come off wing, because they're subjected to that extreme environment.
So that's the technical bit, but in the market itself, what results have you been seeing? Do you think this is changing perceptions of Rolls-Royce and the Trent 1000?
Yeah, well, obviously I spend a lot of time speaking to our customers, and I think it's fair to say there's some trust that's been lost over time. You know, we've caused them disruption, which is why we've been laser focused on trying to rectify that. I would say the conversations have started to change now towards cautious optimism and a sense that the tide is beginning to turn. But we know there's still more to do, and we are laser focused on making sure that we deliver on all of our ongoing commitments to the customers. Some, I guess, pointers towards how that sentiment is changing was recently from Sean Doyle at IATA, who had very much that sentiment that, you know, things are beginning to change for Rolls-Royce.
Sean Doyle, the chief executive of British Airways, of course.
Absolutely, yes. Also, you know, the recent LATAM campaign win, I think, is a good signal that the market's perception of what Rolls-Royce can offer and the product is starting to change.
So things changing definitely in terms of perception. That's really interesting. So Rachel, what's next for Trent 1000 customers and the wider Rolls-Royce customer base? You've been investing heavily in your MRO program. Tell us a little bit about that.
So yeah, we continue to invest in increasing and improving our MRO capacity and also improving our MRO performance, you know, the turn time that it takes an engine to go through the shops. That will continue for many years to come so that we're fit for purpose for the future. We're also continuing to invest in the product itself. The durability enhancements are one step forwards. We're going to continue to improve this product and continue to invest in it, particularly for reliability, for example, and making sure that we are minimising our customers' maintenance burden. So we are not done on the Trent 1000. We're going to keep going.
So lots to look forward to for Trent 1000 customers, and perhaps a corner turn for Rolls-Royce and for the programme itself. Why is that so important, not just for Rolls-Royce, but for Boeing and for the industry at large?
I think you said it at the top. The 787 is the only wide-body programme now that has any competition on it. And having an engine duopoly, it's got to be very important for the industry. You know, competition is what helps us all thrive, and competing against each other makes you strive to go that bit further. So having that competitiveness, I think, is something that is great for the industry in that sense in terms of ingenuity. But the other element is, you know, having that portfolio of supply chain, which we all know in the current climate is very, very important, so that you do have options of different suppliers to go to.
Rachel Walker, thank you very much indeed for telling us about the Trent 1000 and what Rolls-Royce is doing with that, with the programme.
Pleasure. Thank you very much.